Okay, today we're going to be working on the combined gas laws. At the very top of the worksheet, this is the original formula, but we all don't like to work with fractions, so you can go ahead and use this formula right here. Please notice that P1, V1, you expect that to be T1, but it's not, it's T2. Okay, and everything's labeled for you. We'll start with number 1. Please show all your work. You're going to need a separate sheet of paper. You won't get credit. And then if you look at the very bottom, it tells you step 1 and 2. 1, convert all but one temperature to Kelvin. Okay, this one's already in Kelvin. That's the one that you don't have to change, but all the rest of them you do have to change to Kelvin. So you only have to add 273. There's two things you can go about, two ways you could go about it. You can do each problem separately, but what I like to do is just get it out of the way first. So just get your calculator and start adding 273 to every single temperature that says Celsius. I'm only going to do the first 2 for you, and then you guys are on your own for the rest. 25 plus 273 will give me Kelvin. Okay, so this is 298 Kelvin. If you want to box that so you don't get confused. I'm sorry that this doesn't show up very dark. Okay, I'll do it over with pen. Again, that was 298 plus 273. 35 plus 273 gives me 308. So that's what I'm going to be using. I'll go ahead and get the next ones done. 273 plus 15. And that gives me 288 Kelvin. And this last temperature we need to convert to Kelvin, 55 plus 273. 328. Any questions on how you convert to Kelvins? Okay, you're just going to add 273. I'll give you a second to write that down so you can pay attention to what I'm doing instead of just trying to catch up. I'm going to show my work on the paper below. I'm going to plug everything in. Okay, so my P1 is right here. B1. My T2 should be right here. On the very last column, change that to T2. My T2 is 308 equals my P2. Is anybody lost yet at this point? All I'm doing is plugging in the labeled units that are already there for me. This you had to go ahead and change because it says T1 and T1. I did put T2. This is T2. Did anybody get anything different for T2? Okay, let's continue. So then P2, 3.2. V2 is what we're solving for. I just like to work with X rather than putting V2. I know what I'm looking for. If you prefer putting V2, then feel free to do that. The last one is T1, which is 298. I'm going to multiply this all the way across and get it out of the way. Okay? I don't have to rearrange anything on this side. This whole thing you can get rid of and just condense it to one number. So multiply all three of those in your calculator. Did anybody get anything different? Okay. These two right here you can combine. You just multiply them. I'm dropping this down. Just when I multiplied these two, I got, we need to isolate that x all by itself. I'm going to zoom in. How do I get the x all by itself? I need to do the opposite of what it's currently doing. Okay, right now they're being multiplied together, so I'm going to divide from both sides. So this would cancel and I'll be left with x, and x is really our v2. So that's how you find the variable that you're looking for. 4,620 divided by 953.6. So my V2 is 4.84, and the unit for volume, if we go up to the worksheet, liters. Okay. Does anybody have any questions? Do I need to do another one for you? You guys are good. You're good? Okay. Okay, sounds good. Let's flip this around. Make sure you show your work.